Hi you 10, I'm just going to go over this sheet with you just in case you don't want to come onto my Zoom and do it with me. So what you should need to do is you should watch the Maths Antics video just to refresh your memory about all these things. Now he will go through all of these with you. So hopefully you've already watched that. If not, can you pause the video and go to Google Classroom and watch it now. I want you to try and write down what all of these are. So hopefully you know that x to the power of 1 just means we rewrite whatever the base is. Okay, x to the power of 0, that rule is anything to the power of 0 equals 1. Now we learnt all these last year, so this should only be a bit of practice for you. Now today we're going to do to the negative indices. Now last year I got you to fill out a table like this, so I'm going to get you to grab your calculator, pause the video and try and put these in your calculator. So for example, 2 to the power of 4 equals 16. 2 to the power of 3, the power key on my calculator is an X with a little box in the top right corner. You might have X with a Y in the top right corner if you're using a sharp. 2 to the power of 3, when I do that on my calculator, gives me 8. 2 to the power of 2, hopefully you all know 2 squared is 4. 2 to the power of 1, hopefully you just learnt anything to the power of 1 is itself. I'll write that there. Itself meaning whatever the base is. Okay? So on this one here, 2 to the power of 1 is 2. Now 2 to the power of 0, we've just learnt here is anything to the power of 0 equals 1. So this one is going to equal 1. Now let's try 2 to the negative 1. If I put that in my calculator, I get 2. I'm going to press the power key, that's x to the box or x to the power of y on yours. I'm then going to press a negative and then a 1 and I get 0.5. Now if I press my fraction key or my S to D key on my Casio here, it changes it to a fraction for me. And the fraction it changes it to is a half. Now I'm going to try 2 to the power of negative 2. And if I do that, I get 0.25. And if I press my fraction key or my S to D or F to D key, I get 1 over 4. And the last one is 2 to the power of negative 3 if you can't read it. So 2 to the power of, press negative, and then 3, and I get, oh, I'm not going to have enough room, 0.125. And then if I press my fraction key or my F to D or S to D key, I get 1 over 8. So what you should be finding, and hopefully you found this out on the video already, was anything to the negative power actually just puts all of that stuff into the denominator. And that is it. Okay? That's all that a negative index is. It just puts everything into the denominator. Alright? Alright, so you had some examples from the video. Hopefully you've tried all of these. So some of the examples. So x to the negative 1 means, negative means to put the fraction line. Okay, the x to the power of 1 we put down the bottom. Now if there's nothing to put up the top, what do you reckon we put up the top? We've got to put something, we can't leave it blank. So hopefully you realised it's a 1. Now x to the power of 1 we learn up here is just x. So remember, if you ever get to the power of 1, you can just write just the base, nothing else. So let's try the next one, x to the power of negative 2. So that means the x and to the power of 2 goes into the denominator, right? And up the top, well, we've got nothing to put at the top, so we just put a 1. So it's like this negative becomes the fraction line. Okay, and 1 over x squared, well, I can't change it into anything else, so it stays like that. So whenever you see the negative, put the fraction line, and whatever is on either side of the negative goes underneath the fraction line. We're going to do some examples of these soon. And if there's nothing to put on top, we only put a 1 up the top. Okay, and there's another one over here, 2 to the power of negative 3. Remember, the negative means put a fraction line. Whatever is on either side of the negative goes into the bottom of the fraction. There's nothing left to put on the top. We put a 1 on the top, and hopefully you already know from up here that 2 to the power of 3 equals 8. So I can simplify this further and make it 1 over 8. Okay, so the shortcut is, do you see the shortcut? It's just put everything but that negative into the denominator. Okay? Alright, now Maths Antics Man also went over these. So let's just go over them and make sure, because we're going to do these today. This is called raising a power to a power. And hopefully you know, you've watched the video, the shortcut was we're going to multiply the two indexes together. So x to the power of m, brackets is raising a power to a power every time. The shortcut is just to multiply those two together. Okay, now the long way that he did it, let's have a go. He said, right, this is on the inside of the brackets, so that means we're going to write them down as many times as that little number on the outside. So that means I'm going to write down x squared 3 times, because that's a 3, and then I'm going to use, because I'm multiplying, the rule is that I add the indices, so I'm going to add 2 plus 2 plus 2, which hopefully means I get 6. And the shortcut would be to just put a big fat times in between here. Make it big so it makes more sense. Let's get rid of that because I've made that nice and messy. So x times 3, and hopefully you know that 2 times 3, I should say, equals 6. Right, let's try another one. So this one here, it's pretty much nearly the same. It's exactly the same thing. Oops, I was supposed to write that down there. My bad. You can write it there if you want. Alright, so this one here, if you're ready. We did this on Tuesday, so hopefully you should already know these examples. So x to the power of m times x to the power of n. Remember, when we multiply, the rule is add the indices. When we divide, what's the rule again? We subtract the indices. We did that on Tuesday. You may have done Maths Online instead, but you should know that by now. So Mr. Maths on Antics also went over these. This one here, okay, is basically the distributive law. That is, you're expanding the brackets. And it's saying that if there's an m on the outside, then that means you can give an m to the first letter, and you can also give an m to the second letter. Okay, so he said that you are just distributing, or distributing is probably the better way of saying that, and that's exactly what you're doing. You're giving an m to that one, and you're giving an m to that one. Alright, so the same with dividing. Okay, you can still distribute. The x is going to get an n, and the y is going to get an n. So when we write that out, we're going to put an n there, and we're going to put an n there. So that's a little rule you might need to know, and it's just another way to write your answer. Right, so let's have a practice. Now I'm going to go over only a couple. I'm going to leave some blank. Alright, but I'm going to go through this on the Zoom, and I'm going to do all of them, hopefully. So if you want some help, you can watch the Zoom video and check your answers. Otherwise, it is exercise 3G from your textbook. Just look up the answers in the back, okay? Alright, so the first one says y to the power of -3. So I didn't write the question down, but I'm assuming we have to write as a positive index. That's normally what they want us to do. So that means I can't have a negative in my index. Do you remember the shortcut to that one? Remember, minus means fraction line, and anything on either side goes into the denominator. Okay, and then if there's nothing on the top, we put a 1 on the top. Okay, so you can do C on your own in a minute. Now E is a little bit different. I'm going to do it a different colour because I'm getting a bit squishy here. Okay, so again we've got a negative. What did I say to do? Do a fraction line. Now whatever is on either side of the negative, in this case it's an x and a squared, that's all that goes in the bottom. Now this time we're left with something, aren't we? What are we left with? Hopefully you said a 3. So that has to be written in the top. Okay? So if we're left with something that's not on either side of that negative, it goes on the top. So when you get a chance, can you have a go at G? It's the same. Right, different colour. Let's have a go at I. Okay, so the negative is telling me to do my fraction line. What's on either side? A y and a 3. What am I left with? What haven't I done anything with yet? Hopefully you said this. So all of that, 2x, and what was it? A squared? That all goes into the numerator. Ooh, that's a bit more saucy. So you really have to remember what's on either side of the negative. That's the only thing that goes in the denominator. Have a go at I, and I'm going to have a go at K. So pause the video if you want to have a go at K on your own. Otherwise, have a go with me. So first of all, figure out where the negative is. Here it is. So do your fraction line. What's on either side of the negative? I've got an A and I've got a 2. So that goes in the denominator. What's left? I've got a B4 there and I've got a 3 there. So we write the number first, we write the letter second, and that's our answer. Okay, so let's try 6 now. 6a says, now we want to go the other way. So they've got this here. It might be able to help you. Okay, so now we're going from 1 over a to the negative m, and we're going to change it into a positive integer. Okay, this one's a little tricky, isn't it? So what we're going to do here is 1 over b to the negative 4. So instead of this saying, okay, let's do our negative, all right, this is the same as going 1. Now remember, a fraction line means the same as divided by. So 1 divided by b to the negative 4. So I'm going to do my same thing as I did before. 1 divided by, now b to the negative 4, if you remember, means I'm going to do, here's my negative, so I'm going to do my fraction line. The b and the 4 goes on the bottom, the 1 goes on the top. And that's supposed to be divided by, isn't it? Sorry about that. Okay, so we did some algebraic fractions the other day, and we're going to use the same rules. The rules is, if you divide by a fraction, what do you do to that second fraction? Hopefully you said you flip it. So if I flip that, 1, b to the power of 4 over 1, I've flipped it, okay? So that goes there, that goes there, and what do I change my division to? Hopefully you said it times. And what's anything multiplied by 1? Hopefully you said, well, whatever it is. And in this case, it's b to the power of 4, so that's your answer. All right. I'm going to get you to have a go at C on your own. Remember, watch the video at the end. At the end of the lesson, I'll be putting that up when the Zoom's finished. So let's try this one if you're ready. So I'm going to change it into the same as that one up there. I just have to make it big because I won't write neatly. So I'm going to go 2 divided by. Now I'm going to change this one. The negative means a fraction line. I've got a y and a 2 on either side, so that means I've got to put it over 1. Alright, now I've got to use my rule, equals 2 divided by changes to a times, and I flip my fraction. Now remember, anything over 1 means you don't actually need to write the 1. Do you remember that? Okay, so now all I have to do is pretty much just squash those two together. 2 times y squared is just 2y squared. I'll do that in a different colour so you don't actually need to write that. Okay? Alright, now I'll give you a go at G. Pause the video and you can have a go at that one on your own. And here we go if you're ready. So I'm going to do this one with you just to make sure. So let's change it into a division. 5a squared divided by. Now this becomes fraction line. The b and the 3 are on either side, so we make it over 1. Next I change my division to a times, and I flip my fraction. Oh, wrong thing. Sorry about that. Okay, now remember, I don't need the over 1, do I? So I'm going to get rid of that, and it's just 5a squared equals b, but I'll just put it in a different colour so you know it was there. And then equals 5a squared times b cubed, just means I do the 5, then I do the a, and then I do the b, because I can't really combine anything else but squash them together. So you have a go at I now, okay, and I will do it in the answers for you. Alright, so next we're up to question 10. Okay, Okay, we already did, I think, 8 and 9 the other day, so this is why we're jumping. So you might need to watch the Zoom video from Tuesday if you're not sure of these. Okay, so this one's a combination. Here we go. Let's multiply across first. That's what I did last time when we did this on Tuesday. So let's go a to the power of 6, a to the power of 6, times a to the negative 2. So that means we're going to add the indices because we're multiplying. So we're going to go a to the power of 6 plus a to the power of negative 2, and then we're going to go b squared plus b cubed. So I'm going to write that, b squared plus b cubed. Alright, so when we're adding the indices, I don't need to write a second b. Alright, so in your head, can you tell me what 6 plus negative 2 is? Hopefully you said that was 4, and b, 2 plus 3, is 5. Now on the bottom of the fraction, I've still got a7, I'll make that bigger because otherwise it's quite untidy, a7b. So let's use our minus laws here. Okay, well the b's nice and easy. Remember, a b on its own means b to the power of 1, doesn't it? Now remember, 7a's means there's 7a's like this, and 4a's means there's 4a's like this. Now most of the time when you do these, they want you to write your answer as a positive index. I'm sorry I didn't write down the question, naughty miss. So let's see what happens. So the a's, I can cross off 1a for 1a on the top, 1a on the top for 1 on the bottom, 1 on the top for 1 on the bottom. Silly me. Come on. 1a on the top for 1 on the bottom. So on the bottom you should notice we're left with 3a's. That's a times a times a, so we write that as a to the power of 3. So that actually goes, and we're left with a to the power of 3 on the bottom. Now on the top, remember when you divide, you subtract the indices. So for that one, you could just do b, 5 take away 1, gives you b to the power of 4. You could have done it the same way, 5 b's and 1 b, and just crossed off 1 b on the top and 1 b on the bottom, and you should have gotten the same thing. Now some of you might have done this. 4 minus 7 gives me a to the power of negative 3, and then 5 minus 1 gives me b to the power of 4. Now that would still be correct, but if the question said write your answer with positive indices, then that would actually make you incorrect. So just watch out for that. Alright, when you're ready, can you have a go at B? I'm going to do C, and let's see how we go. Now B, of course, the answer will either be at the back of the book, or you can watch the video after I finish zooming. Alright, so I'm going to get a red pen for this one. So let's do the x's. Let's try and see if we can do this one a bit faster. So the x's I can add. 4 plus negative 2 gives me x to the power of, hopefully you said 2. Let's do the y's. We're multiplying, so let's add the indices. y7 plus negative 5. So that's pretty much 7 take away 5, which hopefully you also said was 2. Now I'm going to write down what's on the denominator. Let's go. X squared over x to the power of 4 equals. So notice here, the top number is smaller than the bottom number. Whenever the top number is smaller, that means you're going to have numbers left in the bottom. Okay? So that means if I go, 2 of those go, and I subtract, I'll do it in a different colour so you can see it, that's going to become a 2. So x squared is left on the bottom, so I have to write it on the bottom. And I've just written something. I think I've written that question out incorrectly. I don't know why they'd have x4, x6. Let me have a quick look. What is that? That's question 10. I'll have a quick look. Sorry about this. Question 10. It's not that. Where have I gone? No. Am I in year 10? Yep, I'm pretty sure I am. Okay, I have no idea, but I have definitely stuffed up, haven't I? Is it one of them? I've got no idea. Oh well, let's keep going, shall we? Sorry about that. I think I've stuffed that up. Okay, but anyway, x squared, so the y squared stays on the top. If that's a 6 on the bottom, we should be adding those 6's and the 2 together, and you should end up with y squared over 2 plus 6 makes 8. Okay, 3h. Oh, maybe that's what I was just looking at. Alright, so when you watch the video, hopefully you figured out that anything to the power of 0 equals 1. Okay, oops, sorry about that. Okay, and when you multiply, when you have that brackets, the rule was that you multiply the indices. So it becomes a m times n. Alright, so let's have a go. So the long way, just so you know, a squared brackets to the power of 3 means you're writing out 4 squared, not a squared, miss, 3 times. So if I go 2 times 4 to the power of 2 times 4 to the power of 2 times 4 to the power of 2, the rule is when you multiply you add the indices. So 2 plus 2 plus 2, hopefully you said, makes 6. Right, let's try 2b. So 2b is saying we are writing out the 2a 3 times. So I'm going to do that. 2a, 2a, 2a. So that means you're going 2a times 2 times 2. So we're going to put all the numbers together. Then we're going to put all the a's together. A times a times a. And then you're either going to use your calculator, well in this case we're not, we're just counting how many there are. There are 3 2's, so I'm going to put a 3 in there. And there are 3 a's, so I'm going to put a 3 in there. So that's the long way. Now we're going to practice doing some different styles. Now you remember we wrote down the rules for this one as well. If there's a 4 on the outside, it just means you're repeating whatever's on the inside of the brackets 4 times. So we're just going to do that. We're going to repeat 4 over 7 4 times. And then to figure out or prove the rule, we're going to say how many 4's are there up the top. Hopefully you said there's 4, miss. So we put 4 there. And how many 4's on the bottom? 7's, I mean. There are 4. So all we're doing, if you remember, we are distributing this 4 to not only the 4 on the top, but also the 7 on the bottom. Alright, so 0 index. I'm only going to do a couple. You're going to do the rest, and you can either check your answers or watch my video to find your answers. So remember, the rule is anything to the power of 0 equals 1. So try B and C on your own now. You should be able to work those ones out. Now E, it gets a little bit trickier. This is the only bit that's actually to the power of 0. This actually means 3 times e to the power of 0. So that's the only part we make equal to 1. So if that's the only part we make equal to 1, oh, don't have enough room. What's 3 times 1? Hopefully you said 3. So, same with G. That's got a 0 with it. That's got a 0 with it. So those bits are the only bits that equal 1. 3 to the power of 0 equals 1. 6 to the power of 0 equals 1. What's 1 plus 1? Hopefully you said 2. Have a go at K. See if you can work that one out for yourself. Right, let's try another one. Let's try I. So remember here, the 0 is only with this. Now you could probably look at this one because it's going to be pretty much the same, isn't it? So d to the power of 0 is 1. 3 times 1 is 3. And then we've got to write this on. Take away 2. Can you tell me what 3 minus 2 is? Hopefully you said 1. See if you can do those ones. If there's brackets and there's a 0 on the outside of the brackets, everything is to the power of 0. But we'll watch out for this one. Only this one is to the power of 0. See if you can work that one out. And then L, last but not least, only this one is to the power of 1. And only this one is to the power of 1. So you're actually going 5 times 1 there, plus 4 times 1. See if you can work out what that answer is. Hopefully you got 5 plus 4 is 9. Alright, so the power of a power law is fairly simple. You're just going to multiply the two numbers together, because that means b cubed times b cubed times b cubed times b cubed. So when you add all those cubes up, there's 4 of them, you're going cube, or 3 plus 3 plus 3 plus 3, which is just the same as going 3 times 4, isn't it? And 3 times 4 is our shortcut, which is 12. So you can have a go at B on your own. Now C is pretty much the same. Okay, you multiply the two numbers. What's 3 times 7? Hopefully you said 21. Okay? Alright, now when you get to D, I'm going to leave that one and do E, sorry. Now, the rule still applies, but only with things that are on the inside of the brackets. Okay? So since the 5's on the outside, I'm just going to write 5 down. I can apply the rule, though, to the 9 and the 2. So what's 9 times 2? Hopefully you said 18. Okay? Have a go at D and F. See how you go. Right. When you're ready, pause the video if you need to. I'm going to go on to 5. So now we've got some numbers on the inside of the brackets. So you need to know that this actually means 3x times 3x. Okay? So when you have two numbers, you actually have to multiply them out like normal. What's 3 3's? Hopefully you said 9. And then x times x, how do we write that? We write x squared. Alright? Let's try this one. Now this, in long terms, means 4m times 4m times 4m. Remember that. So you have to go 4 times 4 times 4. I suggest you do that on a calculator. 4 times 4 times 4. That's 64. And how many m's do we have? We have m cubed. Okay? So watch out for those. They're a bit trickier. Right, so let's do some more. You can do D. I'm going to go over E and G, and then you can try the rest and watch my video if you want the answers. So remember, it means x squared y, I'm doing E right now, written out 5 times. Now if you don't want to do that, because it does get a little cumbersome, you can write it out like this. So just the way we were doing the distributive property before, I'm going to multiply the x squared by 5, and then I'm going to take the y out, and I'm going to multiply it by 5. Now remember, if it's a y on its own, that means it's to the power of 1. Okay? So if I do x 2 times 5, what do I get? Hopefully you said 10. And if I do y 1 times 5, I get y to the power of 5. Alright, let's try f just to be sure. Now these ones are tricky. When you've got the numbers, you have to remember you're either going to do it this way. I'll do it in 2 different colours so you can see it. You're either going to go, now I suggest until you get really good at these, you do them both ways. Oh, sorry about that. Okay, so that's one way. The other way is to do this. You do the brackets, the expanding brackets, the distributive like this one here. So the first term is a 3. The second term is an a cubed. Now remember the rule for this one is multiply by the indices. Okay? Now the same rule can apply with the 3. 3 on its own just means 3 to the power of 1. So then when I times this one by 3, that's what it's going to turn out by. So let's do them both ways. See how we go. Let's try the blue way first. So when I do the blue way, I have to go 3 times 3 times 3. Now do it on your calculator, 3 times 3 times 3, to make sure you get the right answer. Because most people go, oh, it's 3 times 3, oh, it's 9. And it's not, okay? It's actually 3 times 3, which is 9, times another 3, 9 times 3, which is 27, okay? So that becomes 27. And then we add all the a to the power of 3's together. 3 plus 3 plus 3 makes 9. Now, if you want to do it the green way, I'll get rid of that, sorry, and do it in green. It's the same question. You're going to do 3. 1 times 3 gives you 3 to the power of 3. Now you can do that on your calculator. 3, press your power key, either y to the power of x, or x to the power of y, or x to the power of box, and then a little 3 up the top, and that will give you 27. I'll just write it over here. And then a to the power of 3 times 3, well, hopefully you already know that 3 times 3 is 9, so then we just have to write that again over here. Notice, same answer. Okay, so it doesn't matter how you do it, you should get the same answer. But just watch those numbers out the front, they can be tricky. Alright, so if you think you know what you're doing, can you have a go at G and I? I'm going to go over J now. Alright, J is now a fraction. So you're just sharing the squared with both of those terms. Okay, so we're distributing the 2, or the squared. So the x gets a squared on top, and the 5 gets a squared on the bottom. You just have to remember, x squared I can't simplify, but I can do 5 squared. Do you remember what 5 times 5 is? Hopefully you said 25. Beautiful. Alright, so have a go at K. I'm going to do M. So same sort of thing. I'm going to share the 3 with the top and the bottom. Now remember, a brackets means I'm multiplying. So x 2 times 3 gives me 6. Now the y doesn't have anything there, but it should have a 1, we just don't write it in. So what's 1 times 3? It's 3. Okay? Alright, P. You can have a go at O on yourself, by yourself. Here's P, 2/3 to the negative 1. Alright, this one's a bit tricky, because that negative means I put the fraction line in, doesn't it? But when you have a fraction, it actually is telling you to flip the fraction. So that's the shortcut here, and they didn't really tell you that, did they? So I need, when I've got a fraction to the negative, it actually means to flip the whole fraction. So that means the 2 goes on the bottom and the 3 goes on the top. So that one's a bit tricky. Watch out for that one. Same with this one. Flip the fraction. 5 will go on the top, x on the bottom. Okay, question 6. I think we're nearly done. Ooh, got lots here, haven't we? How many more pages have I done for you? Oh, goodness, only 2 more. Thank goodness, hey? Alright, let's try 6. So I'm going to leave you B, because we did ones kind of like that. My hint is multiply the tops together. So remember, the rule is add the indices and then subtract the bottoms. Alright, I'll do that answer on the Zoom. Let's try this one, E. So remember, you've got to distribute the 2, or you can expand it. It's totally up to you. You find the way you want to do it. I'm going to distribute. So that means I get 5 squared and R 6 times 2. Okay, and I'm going to just write that on the bottom so I don't forget it. And there's not a lot of room, so I should have written that smaller. Anyway, here we go. Okay, equals, what's 5 squared? Hopefully you said 25. And what's 6 times 2? Hopefully you said 12. And then I'll just rewrite that there. Now I've got a division. Alright, what's the rule for when you're dividing? You subtract the indices. Remember that? So what's 12 take away 8? 12 take away 8 is 4. Now the bigger number is on the top, so the R4 will go on the top. Now I'm just going to use my numbers, so that crosses out and that becomes a 4. I'm going to use my calculator just to check the numbers. 25, fraction key 3, doesn't actually break down, it stays as 25 over 3, and remember, in algebra we leave our answers always as improper. Improper fractions. Alright, so let's have a go at G, and you can try F and H on your own. Alright, so M to the negative 4. Remember, the negative means draw a fraction line. The M and the 4 go on the bottom, the 1 goes on the top. Anything to the power of 0 equals 1. Now the 4's on the outside, so that means I'm going to go plus 4 times 1. So that's, sorry about that, plus 4. Do they have the same denominator? Normally 4 on its own is 4 over 1. No, they don't. So your answer is just 1 over m to the power of 4 plus 4. Right, yes, I know they don't make any sense at all, but they're just practice. Can you try F and H? I'm going to go over the rest of these so I can go to bed soon. Alright, question 8. Try not to use a calculator. See if you can work these out without. You may, to check your answers. So, Remember the negative means, oh, no pen miss, oh, yep, that'll do me, thank you. The negative means fraction line. The 2 and the 2 go on the bottom, 2 to the power of 2. There's nothing left, so I'm going to put a 1 on the top. What's 2 squared on the bottom there? Hopefully you said 4. There you go. That wasn't too bad, was it? Okay, now B is a bit harder. I'm going to leave you for B and I'm going to do C, and then you can see what happens and try B on your own. These ones are a bit harder. So when the negative is on the bottom, similar to when we did the fraction, it means that you need to flip all of this, not the 5, up to the top. Okay? We take out the minus when we do that. So the 5 stays where it is. I'm going to leave it there. And the 2 and the 3 flip up to the top. Now as soon as you've moved it, you don't need the negative anymore. That becomes a times. There's nothing left on the bottom, so we put it over 1. Now use your calculator or your head. 2 to the power of 3 means 2 times 2 times 2. That means 2 times 2 is 4, and then 2 times 4 is 8. So that means 8. Can you tell me what 8 times 5 is? Hopefully you said 40. Now your calculator will do that for you, but of course if it asks you to do it without a calculator, you have to show that you understand the index laws. Right, let's have a go at D. Alright, what does brackets mean again? Brackets means multiply. So 5, 2 times 2 is 5 to the power of 4. 5 to the power of 4 on the bottom. What's the rule when we have the same thing on the top that's also on the bottom? Same thing on the top, so if it was just 2 over 2, you'd say the answer was? Hopefully you said 1. If it's just x over x, the answer is 1. So 5 to the power of 4 over 5 to the power of 4 is just 1. Beautiful. Alright, now these ones get a bit trickier. I'll try E and I'll get you to do F on your own. So the problem with these ones is you'll notice the base, that's the 6 and the 36, they're not the same. If they're not the same, you can't do any of the index laws. So let's see if we can change them somehow so they are the same. Now, do you know what gives you 36? Hopefully you said, well, I know that 6 times 6 is 36, and 6 times 6 can be written as 6 squared. Do you agree? Now, I haven't done anything with this yet. I've only just changed the 36. So that goes on the outside. Okay? And then over here, I write what's on the bottom. On the bottom. Sorry, should have made that a bit smaller. Okay, now let's apply our rule. Here, I'll do it in a different colour. When we have brackets, it's raising a power to a power, so we multiply the indices. That gives me 2 times 2 is 4, and this one stays as 6 to the power of 4. And the same as what we did a minute ago over there, if they're the same thing, they cancel each other out, and they equal 1. See if you can do F on your own. Okay, here are some harder ones. I'm going to do 2 of them, and then I'm going to bed. Alright, I'm going to leave you with A, because I reckon you might be able to do A on your own. Let's have a go at B. Now these numbers are out the front. If they're out the front, you can just multiply them together. 4 times 3 is 12. So now I have to distribute this 3, because it's on the outside of the brackets, with both of the letters on the inside. So I'm going to do that first. So that means A, 2 times 3 makes 6. And B, remember that's normally a 1. B, 1 times 3 makes 3. Now there's a times in between, so I can still put a times. And I'm going to distribute that 3 with the A and that 3 with the B. Now there's nothing there, which means it's a 1. So 1 times 3 is A3. Oops. And 1 times 3 with a B also means B to the power of 3. So now I just have to combine. The rule is when you multiply, you add the indices. Now I've already multiplied the numbers together, so that stays as a 12. Stop doing that, silly iPad. But let's look at our A's. I've got A to the power of 6. Let's do it in a different colour. So I can add that with the 3. What's 6 plus 3? Hopefully you said A to the power of 9. And different colour. Purple's my favourite. Let's go. Let's add the B's together. I've got a B3 and a B3. What's 3 plus 3? Hopefully you said B to the power of 6. Okay? Now you're going to have a go at some of these. I'm going to do these on the video. Off you go, and I will see you tomorrow, hopefully. Or you'll be watching this and it'll already be Thursday. So I'll see you then. Bye.